So let's look at digital impressions a little bit closer. Well, what is it about digital impressions that are advantages that make it useful for us in our dental practice? Well, for one thing, it's simple. We don't have a large armamentarium of things, no tray, no syringe, no material, no two parts of material have to mix together. All of those make that a much simpler procedure. We simply turn on the scanner and go in the mouth and take those scans. It is versatile. Allows us to be able to use for restorative, allows us to be able to use for orthodontics, allows us to be able to move into a digital platform to be able to send our files that we create outside from the scanner to be different things. We can create a virtual planning platform, for example, to be able to create precise surgical guides. We can make precise provisionals. We can mill with it. We can send the information to very precise mills to be able to make crowns, bridges, and work in a 100% model-less environment, all because it is digital. Again, making the point for the versatility of digital impressions. Allows us to save money. The consumables that we would spend for our VPS, for our alginate impression materials, are no longer necessary when we work with digital scanning. It's highly accurate. I'm going to make that case for you in just a few minutes as we move our way through the slides. And of course, it allows us to reduce our working time. Again, we'll make a case for how fast it is that we can make for our scan times with the different types of scanners. Now, there are differences, and we're going to go over some differences between the different types of scanners. And I'd like to start really with an overview of what the original scanners really were. And there were really two types. One was a technology called triangulation sampling, which you see in the screen on the right-hand side. And a second technology called parallel confocal. And I'd like to contrast those two technologies because they really were where we started. With triangulation sampling, as you can see in the screen, we took and used a beam of light that then allows us to capture information at a certain focal length. These systems, not to get too technical with the technology itself, just know that the triangulation method, when we started, required a powdering, dusting, opacering, it was called, a way that we could make it so that the optical qualities of the information that we received on the scanner was even. For example, the blackness of an amalgam or the shininess of gold, for example, would be masked and made equal or even in optical quality by using this powdering, dusting, or opacering. And you can see in the screenshot on the far right what it looked like to do this powdering or dusting in the mouth. The takeaway from this slide is that when you look for a scanning system like the iTero element system, try to stay away from the powdering systems because they are cumbersome. They're expensive for the more expenses involved to have to buy the powdering material itself, and make it more difficult, I think, for operators to scan than systems that don't require that. Now, in contrast to the triangulation sampling is the parallel confocal method. Parallel confocal, which I think is very adaptable to curved surfaces, basically sends out this image. It sends out the light from the wand, and it receives back the information in a series of tomographic slices, and that helps to be able to grab and capture the curves of teeth and makes a nice capture system that also does not require powdering, dusting, opacering, and therefore makes it more amenable and easier to use in the private practice. 1,000 points of data, overlapping stitching it's called, allows this three-dimensional information to be transmitted onto into the capture and the wand and then onto the computer screen itself. Again, and you see it on the slide, that is a powder-free system. Just another screenshot to show you a picture, an idea of what it looks like to assimilate data using this parallel confocal system, which is part of the iTero system. The new element actually adds not only the parallel retains the iTero not only retains the parallel confocal system of capture, but it adds high definition video as the actual ongoing capture system, which we'll look at here in just a second. You'll see in the screen there is on the left-hand side, a picture of what the old original unit looked like. There's a screenshot of what was the last system you can see, in this big, large cart that was moved around from room to room. Certainly worked fine, but you can see with progress we've made leaps and bounds to what is now the iTero element. You see that in the right-hand side. That contains a screen, a stand. You can use the system either as a freestanding screen or in the stand system that you see on this screen. Let's take a closer look at some of the ergonomic innovations and some of the updated issues that we see, some of the updated features that we see with the new element. And so we're going to meet and look and talk to the new element here on the screen. We're all used to using screens now that have touch screen, and this is a touch screen system. Certified connectivity to different workflows. What that means is we've worked out different ways. iTero has worked out different ways to send its data to prescribed receivers. For example, iTero is capable of sending its information directly out for Invisalign submission. So that's an example of connectivity that's been worked out. For example, connectivity to the iOS Fast Design mill so that the information leaves the iTero and goes to the iTero, leaves the information from the operatory, from the source that it was taken with, and sends it directly to the mill in your office, are examples of certified connectivity. There are some advanced wand features we'll look at in another slide. We'll get to that. It is a very small unit that moves easily from operatory to operatory. The wheels are distributed so that they distribute the load and make it easy again to be able to move from operatory to operatory. The wand itself is about 40% smaller and lighter than it was in the last system, the system that you saw in the middle part of the screen in the prior slide. And the capture system is much faster. Here at the bottom of the screen, 6,000 frames per second. That's as compared to about 800 in the last system. The screen, as I pointed out, is a high-definition multi-touch display. Very intuitive to be able to use. Closely look at the screen on this slide, and you'll see an image of teeth, and down in the lower left-hand corner you can see what appears to be a screenshot of gums and teeth. What that actually represents is that when you scan, you can see a live picture of exactly what it is that the wand is seeing or capturing. At the same time, on the right-hand side of the screen, you can see the virtual representation of that image on the screen as it has been turned into you'll see real-time visualization of what is a virtual representation of the teeth. Again, a lighter wand. It allows for color scanning, and you can actually see what you'll see in a slide coming up in just a minute. You can use a color view feature, and you can use the system either as a counter stand, or you can use it as a full-on as a counter or a full-on stand that rolls around that I showed you before. It's about 20 times faster in terms of its processing system, and again, it has the 3D video capture so that the wand is able to move really at a very rapid pace from tooth to tooth as you move through the mouth. You can see in this picture, we'll talk a little bit about the wand, which has some unique features. In holding the wand, you're able to, of course, it's plug and play. You can take the wand, plug it into its USB port on the computer screen that you saw earlier in the prior slides. There is a system that allows you that has a defogger, a little small compressor blows warm air on the teeth, which means that you have an opportunity to be able to work as a solo operator and not depend on an assistant. A lot of other systems require an assistant to be able to manage, especially in the case where you have powdering or dusting to have to deal with. There is a gyro technology that allows you to be able to use the wand to rotate the images that you see on the screen, and a redesigned and smaller wand than what was the case in the past technology. This is an overview just to say these are the general dimensions, and in summary of what we see on the screen, It's about the size, the screen is about the size as a large laptop. And I think all of us are familiar with that. Let's take a look at how a market overview of how these different systems that we had when we first started really evolved. There are lots of systems. I've listed several here on the screen. And all of the different systems that we first looked at had challenges, different challenges with different systems. Well, let's just talk about a few. We've already summarized and talked about powder. We haven't talked about why powder is so much of a problem. But one of the problems, especially in the case of Invisalign, is that the powder tends to pool in the interproximal areas. And as it does, it may make for ill-fitting aligners. Align, as it looked around at the different types of companies that it wanted to partner with to be able to use digital scanning, thought this would be a problem for the folks that had dusting, opacering, or powdering systems. Another issue is that some of the systems, especially the triangulation systems, require that you hover at a prescribed focal length above the teeth. And that hovering can be very fatiguing, and it also has a huge learning curve, making it difficult to transpose that information to an assistant or staff. I think it's important when you think about a different system that you think about a scanner that allows you to rest on the teeth. I've used most of the other systems and found that this feature of resting on the teeth is very important and as I said, much less fatiguing. The issue of encrypted files. Some of the files that are encrypted are more difficult to export. And encrypted, and we all hear and know, and I'm sure you folks out there are much more savvy about encryption than I am, but just know that encryption makes it difficult to send the files can make it difficult to send it from a system to another system. Let's stop for just a minute and think. The open source system of Itero lets me send my STL files, for example, to my computer that I manipulate those files to be able to send to my 3D printers. If I have an encrypted file, I don't have a way that I can send that STL file easily to that computer to be able to then use my 3D printer. So the open source is an issue, and it is, I think, something that you think about, and I think it's important for you to think about using a system that doesn't require an encrypted file to be able to then export your STL files. By the way, STL, for those folks that don't know, is standard tessellation language and is the file type that we use to be able to describe the Itero file, the digital scan. It is the common file system used for digital scanning. Often, some of the scanners that we've seen in the past just simply take too many scans and therefore make it cumbersome to be able to use, and again, make it difficult to train new operators. The learning curve may be high, and if that is the case, that's a challenge in your office. The wand itself often has been critiqued, and we've got to think about the size of the wand, and I want to stay here for just a second and talk about wand size. The wand size is important. It can't be too small, and the reason for not too small is that when you press the wand against, for example, the buccal tissue to push the cheek out of the way, and it folds over top of the head, it makes it difficult to capture the information. The wand then can work like a really nice retractor. So there's a sweet spot between a wand that has a head that's too big and a wand that's too small. And when you look and think about what's going to be happening in the future or what type of digital scanning system you want for your office, think about the huge advantage of using a digital scanner that has a head that you can use as a retraction tool. And I think the sweet spot now is what we found in the Itero element system to be able to use its head as a retractor for the tissue. Some systems have limited software, meaning that there are some things that you can't do. For example, margin marking can in some cases be done only by a lab. We'd again like for systems to be able to include features that allow us to do the full gamut of things that we want for our restorative solutions. Often, in cases where milling is linked to, or there's a workflow with mills to different systems, one of the things to look out for is whether or not the milling materials themselves are limited. Now, just some things to think about, some challenges that we found with the different systems. So rather than be specific, lump them together and just say these are the different systems that we might see. There are lots of systems. Here they are in the screen, just as some examples. And at the bottom of the screen, you see some sample examples of the different kinds of in-office milling options. Just for the record, I use the iTero Element, and I use the iOS TS150 milling system, which you can see I'm highlighting here on the screen. Now, let's take a few minutes just to look at a comparison between intraoral scanners. And I don't mean this by way of a comparison that points fingers at good or bad, but just by way of things that actually are what we have now to work with for the different scanners. I'm going to use the iTero Element, the 3M True Definition, the Sirona CIRAC OmniCam, and the 3-Shape Trios. And rather than read all of the slide to you, let's just say that Invisalign, you can see, I'm going to run that across the top. Invisalign in the first three is a workflow that is accepted. Trios, others will probably come in the future, but not as yet Align has not as yet allowed for integration with Invisalign submission. And you have to, again, look at these different features as you start to look at what you may or may not want for an actual scanner. We'll look at, as we go through, some of the other features, and by default, look at what might be features that you may or may not be as important as other features. I remember I told you that there was this issue of hovering. In the case of the Element, you can rest on the teeth. In the case of the True Definition, you must hover at a certain 5 to 15 millimeter distance from the teeth. You can touch the teeth and or hover in the case of the Sirona OmniCam, the CIRAC system. And in the case of the Trios, you must have a certain acceptable distance to hover. I'm making the point that these systems are different, and simply going and saying a scanner is a scanner is a scanner is not the case. When you get out, things may be different. When you guys graduate from school, it may be different, but right now, these are just some things to think about. Now, there's the issue of accuracy and resolution. If you look closely, you can see three examples. On the left-hand screen, let's look at what would be all the data in a lumped area, but it missed the target. It wasn't precise in that particular, in the area of accuracy. So that first graphic says that's poor accuracy, but good, you can see the clump data resolution. All the way to the right, here we have data that's all over the place, and we have good accuracy and poor resolution. What we like to have would be good accuracy, meaning we have nice, correct dimensional relationships, teeth, gingiva, resulting in nice, good margins, closed contacts, good occlusal registration, and good resolution, which allows us to see the very fine features, subtle surface changes. Let's look closer at the issue of accuracy and resolution, and we'll make a little comparison of different systems. You can see here is a chart, which we'll look at in closer detail, and we're going to look at a comparison between the accuracy of impression taking and stone models versus digital. Look closely at the slide, and I'm going to hit the next button, and you'll see, if you look closely, you'll see in green, and if you look, I'm going to slide back on this in just a second. You can see this very high detail in the occlusal portion. The green is a digital representation of the exact same, is a digital representation of the exact same thing. So here you can see how inaccurate it looks to see the occlusal in the stone model, and how highly accurate is the digital scan. Let's move forward. Here is a cross section, and what we've done is to take and look at a stone model and compared it to an intraoral scan. And if you look closely, you can see the red or orange represents a cross-sectional view of the stone model, and the green represents the high accuracy of the intraoral digital scan. Finite element scans have shown the accuracy of intraoral digital scanning. Let's talk for a minute about what we end up with digital scanning. We can use scanned, because we can go to a computer screen and we can work in a 100% digital environment. We can do modelless crowns. And let's look, here's some data from Glidewell, one of the largest, if not the largest, dental laboratories in the country. And we've asked Glidewell, how are we doing with these kinds of modelless crowns? Are they working better than the conventional models of conventional crowns that are made using the conventional process on conventional stone dies? The answer, modelless crowns, about 80% reduction in returns for margin errors. That's pretty awesome for the lab and for the doctor. 60% reduction in returns for occlusion, 55% reduction in returns for fit issues, and about 30% overall reduction in remakes. That's pretty amazing stuff. If you'll look in the screen, and what we learned from this graph is that from the get-go, which was about October of 09, you can see there's been a continuous trend in an increase in Glidewell, the lab, doing workflow digital with digital impressions as opposed to conventional stone. That continuum you can see in the kinds of impressions and the kinds of digital scan submissions that we are getting. You can see here some of the companies not so much. Here's CIRAC. You can see Cadent is one of the largest or the largest submitter of a recipient of digital information to be able to make crowns. Here's Total Digital on the far up on this as a comparison. Total digital, and you can see the piece of the pie that Cadent is doing with the reception by the lab of its impression taking. Now, digital scanning to make crowns. Are we exceeding? Where are we on the continuum? The standard that we've had has been the porcelain fused to metal crown, the PFM. As you can see in this graph, the monolithic ceramic restorations now exceed, and here I guess in about the year 2010, the submissions of the monolithic ceramic material, and that would include zirconia and include lithium silicate and lithium disilicate. The EMAX being an example of the lithium disilicate, exceeded the submissions of the PFM, the old standard. How accurate? Let's take a look. There is a standard. It's called the ADA Specification 19, or ISO 4823-2000. And basically, we'll use a cylinder that has some markings on it. The impression material then is measured against the standard of this ISO standard to see whether or not it is a material that is acceptable within the range of that standard. Let's compare that to what we see with a digital scanner. Here you can see a scanner. If you look closer, you can actually see their errors in capturing the groove that runs through that standard. Here is an example with some stitching errors, and here is an accurate, good scan with good resolution, good accuracy, good resolution that you can see from a good digital scan. Now, let's compare something simple. Here's a penny, here's a stone model cord, and here's a digital scan. All are reasonable scans, but I think we'll agree that the accuracy with digital scanning exceeds that of our stone, of where we are with stone modeling from conventional impression taking. Here's some pictures that show us what it looks like to scan teeth, because so far we haven't talked about teeth, we've just been talking about things. Let's compare some different systems. Trios, iOS Fast Design, the Sirona system, the Cadent system, and the E4D. Interestingly, all in terms of average deviation are very close. Now, in terms of standard deviation, the smaller the number, the more accurate the impression, or the more accurate the digital scan. And you can see Cadent comes out with its parallel confocal as a very accurate, the lowest or smallest standard deviation in this particular study that came from Glidewell. Now, how does the process itself work? Well, it's just the way that we use for conventional. We'll cut a prep, we'll retract the tissue, we'll scan. The scan is then cleaned up in virtual world in real time. We'll view and evaluate the digital image in real time. The user may mark the margins, evaluate and add scans. The data is then sent to, in this case, Align Technology or onto a dental lab of some kind, maybe Glidewell or whoever that might be. The polyurethane models are then cleaned. The polyurethane models, we may use modeling. We may use that by way of milled urethane models with very accurate dyes. And so if a practitioner decided he wanted to use his own lab, which is very sensitive to a lot of folks, they have a relationship with our local lab, you can still maintain that relationship by using milled models. Those milled models with accurate dyes, with very little dye wobble, can be sent to your lab to create the restorations that you may choose. You can also work in Modeless world with ceramic restorations or zirconia restorations as a all-digital workflow. The restoration is then returned for delivery. So let's follow through that with some pictures. Here we have our digital scan. This is our iTero scanner, again resting on the teeth, the ability to be able to capture a steady image. We can review the scan. This is what's called the Occlusal. This is what's called the clearance tool, to be able to see if you do in fact have enough clearance with a color guide. If we want to use the modeling feature, we can order models. You can see here in this particular case, here is a model on an articulator where we use the modeling process. Or you can see in the bottom slide, this is a picture from my office, a roundhouse, all zirconia bridge here placed in the mouth. And we can work in Modeless world with a 100% digital workflow. Let's look at some of the tools that we have with the, let's look at some of the tools that we actually have with our scanning system. Here, for example, and now we're in scan mode. What does that mean? I've turned on the unit, I've turned on the wand, and I'm going to then, in real time, move the wand progressively from side to side, rolling the wand over top of the teeth so that I capture the information. And I can see in the lower left-hand screen what I actually see in the direction the wand is pointed. In real time, I'm seeing the teeth, for example, the gums. Now, on the right-hand side, I'm going to see a reconstruction of that information instantaneously on the screen. That is a virtual representation of what will be sent to the lab. If I have an area that I want to rescan, and here you can see this shows you that, I simply circle that area and it lets me rescan that area and reconstruct that area as part of the virtual representation. Here is a feature that allows me to be able to choose. You can see here are the upper teeth. I have the target tooth for my prep in the lower arch. That's the prepped arch. And I'm going to be able to look at the opposing and to be able to evaluate the opposing teeth and evaluate the opposing arch. Here is a, again, clearance tool I showed you before, which allows with a graphic representation in a color scheme to be able to see whether or not there is sufficient clearance. In the next slide, here you can see where red shows the teeth are in fact making a full contact in maximum intercuspation, and you can see the blue indicates a depth, which is indicated in the graphic, the color display, and that allows me to be able to evaluate using this clearance tool whether or not I need to make any more reduction or if I have sufficient reduction. I also can work in two different modes. I can, in process mode, I can go to a color view tool that allows me to see things in color. A lot of doctors like this because it allows you to see a difference in the cut crown margin and in the gingiva with two different colors using this color mode. That is keyed by way of this tool over here on the left, and you saw before the Occlusal clearance tool, which is this tool here on the right of the screen of the models above it. And lastly, there is a tool that allows you to be able to outline in the process mode. We're not in scan mode now, we're in process mode. And here's an area where we think we might, let's say, have not captured the full margin as we want. Draw a circle around it, that area is highlighted, take another scan, and it's automatically stitched back in place. There are some tools that we use on the orthodontic side. The first tool I'm going to talk about is a tool we use with Invisalign submission, a very useful tool that allows us to be able, what's called an outcome simulator. It allows us to be able to create a simulation of what the teeth will look like at the start, of course, and where the teeth will finish in a proposed sequence of treatment. Here you can see this would be the final stage, and if I decide that I might want to modify that, I can take the tool, highlight the feature, in this case the extrusion-intrusion tool, highlight that particular tooth, and in real time, in front of the patient, with them in the chair, I can literally wow them with the technology to be able to allow them to be able to move that tooth. Here you can see we've taken the lateral and just simply moved it into a more extruded position. It's used as a communication tool to be able to show patients what this high level of technology is really all about. We have different views, and here you can see I'm going to show you those different views from the bottom to the top. There is a occlusal clearance, or a amount of, we call it an occlusogram, that allows us to see how much functionality there is to the occlusion, and a template which allows us to put the teeth in this different position that you see. I can put the models with the occlusogram on to be able to visualize that amount of occlusion with the color graphed, and I have a way that I can change what the view might be, from a template view to a side-by-side view to a single view, which you see on the screen in front of you right now. Again, just giving you an idea of what these different views are all about. Well, it's kind of important. How much time does it take to do a scan? This is, on this screen, a slide that I've used in the past to describe the scanning time that it took for our past system, the old 2.9 system. Upper, about 2 minutes. Lower, about 2 minutes, and about a minute or so for the centric. Put that together, about 5 minutes of scan time. Now let's look at the next slide. In the next slide, you can see, here I'm using the element scanner, and look, that time is cut by half, about 2.5 minutes. A minute, and this is using parallel confocal with high-definition video to be able to work quickly through the arch, do upper, lower, and the centric in about 2.5 minutes. Well, let's talk for a minute about where we've been. And we're going to take some questions here in just another couple of slides. The first iTero unit came out in the spring of 2006. That's been 10 years ago. 10 years ago. We have used with this system an open platform, again an open source system, not an encrypted file, allowed us to deliver the full range of restorative solutions: ceramic, metal, porcelain fused to metal, full coverage, inlays, onlays, veneers, provisionals. Let's go back and highlight metal. Yes, using milled models, using dyes in the conventional lost wax process, we can use the metal, the PFM system, using this system of digital scanning. We also have mountings on very precise metal hinge articulators that come from iTero. You saw those in the prior slides that I showed. And we have specific mounting to whip mixed and our Hanau semi-fixed articulators, allowing us to do more complex systems. We can have scans that produce models on which we can do all the things that we do with thermoplastic technology. Full arch scans for Invisalign submission. Of course, we talked about the Modeless restorations, the 100% workflow to be able to have labs make us modelless restorations. And we talked about, we will also add that we can talk about, and we'll talk more about this in the next coming weeks, implant scan bodies that we then can use to be able to determine exactly where the implant, the head of the implant is actually located, so that we can, in virtual world, make restorations for that. We'll learn to merge DICOM. We now use, and we'll show you guys in the future, the merge of DICOM files and STL files to create a virtual planning platform on which we can create precise surgical guides and place our implants, and even make our pre-planned immediate provisionals to be placed at the same time as the placement of those implants. And of course, the world is wide open for what we'll be doing in the future. Your world, your future, will be using digital scanners that will have a workflow with 3D printers. We're doing that currently in my office, and we'll talk a little more about that in the future. We have as a summary of what we've talked about, found that the elimination of the uncomfortable experience for our patients has helped us to eliminate traditional impression taking in our practice with digital scanning. It's helped us to optimize our Invisalign submissions. It helped me to enhance my reputation as a high-quality practice. Helped me to utilize digital technology to be able to maximize its potential, do the things that we really can do for making superior restorations. Achieve no fitting and very little adjustment restorations, improve patient satisfaction, and of course reduce consumable expenses and realize improved clinical results. Now, what I'd like to do is to find out, I think this ends my part of the presentation, I would like to take questions. If there are any questions, I will try to answer those questions. And I still don't have communication with Rich. Let's see if we have anything down here at the bottom that I can help with. First question, what is your best recommendation for a student who is interested in getting started on the journey to digital impressions? If you don't mind, I'm going to see if we have, I'm trying to work between two. Okay, good. I would say the best thing that you can look at as a student to be able to think about your journey into the world of digital impressions is to actually see if you can find a digital scanner to put your hands on and practice with. There's certainly many different scanners out there. In my opinion, having used lots of different scanners, I think the iTero scanner is pretty much a revolution to the world of digital scanning, and I think be a big plus if you can find an iTero scanner to be able to use. There's many opportunities to be able to meet and talk with representatives from the iTero company to be able to show you and have you learn about a digital scanner. I think that might be a good way. There are articles. I wrote an article in the Journal of Clinical Orthodontics last year. I think was in April of 2015, and listed various different digital scanners with information about the properties of those scanners as a comparison article. You can probably Google that easily on an easy computer search. Let's see if I can find another question down here. What is the initial monetary investment of the digital scanner? Good question. Again, if you'll go back to the article that I had in the JCO, the Journal of Clinical Orthodontics, there is a comparison. It does compare costs of the then available scanners, and I'll just say in a kind of a number that puts it into a lump sum. They actually have different ways that they market the scanner. Some with larger software packages and some with less software package and more upfront cost. In general, I think you'll probably look at the range of $20,000 to $30,000 as a good number to think about a scanner. In my opinion, that is a bargain basement price for all of the things that we can do and all of the benefits all of the benefits that we can reap for a scanner. Whose research are you reading in digital dentistry? And I got to say, I don't think I can, of course, my article in the Journal of, in the JCO, the Journal of Clinical Orthodontics, was a peer-reviewed article. And if you wanted an article to look, that would be an article to go to. There is a bibliography in that article. So a simple way to answer that question is to say, if you want a bibliography of information in the digital world, I think an article like the article that I published would be a simple, easy place to go and look at the bibliography we had from that peer-reviewed journal. I hope that helps. I don't have anything off the top of my head for that. I'm looking to see if there's any other question. Rich, do you see? Here's another question. Starting out, should you buy the scanner and the printer? At this point, that's a good question. That's a different question than should you buy the scanner and a mill. And the answer is you need to kind of look and see what the return of investment is for in-office milling. As far as a 3D printer I think has three different properties that are valuable to a general dentist. One, it can make models, and on those models we can do all the things that we ordinarily do out of stone. However, we do it with a material that doesn't break, certainly doesn't break like a stone model, and a material that's much more accurate. So all of those things that we made with thermoplastic materials, retainers, bleaching trays, sleep appliances, all of the different things that we have in thermoplastic materials making, movement appliances, etc., are things that make, that is one of the advantages of a 3D printer. Another thing is that we can make surgical guides, and the third thing is we can make provisionals. We now have materials that are FDA approved for use in the mouth, so we have now opened up the world of provisionalization, or making provisionals. Those three things I think will be common things that you'll see done on 3D printers in a doctor's office. Now back to your point. Buying a 3D printer at this point is not plug and play. It's going to take a little while for that to be made for dentistry. My 3D printers were industrial printers that I used to develop and understand and find what worked in dentistry. I have a Stratasys printer, an Envision Tech for Factory 4 printer, and a Form 1 printer. And again, those are printers that we've had to learn to use, but are not specifically built and made for dentistry. I think you will see that come in the future, but we're not quite there as yet. The mill, we can make the case for milling and digital scanning is a nice mix. We are in my office now every day milling zirconia, and we thought for a while that it wasn't going to be possible to mill zirconia, a very hard material, very difficult to mill with diamonds, and working through the problems that we have to make that work. I gave a paper at the Greater New York Dental Meeting this past December and demonstrated about 14 specific cases that we had great success with doing in-house zirconia milling. In fact, it's become so easy now with zirconia, milling zirconia, that we can produce a crown in an hour. I think that's phenomenal. I actually did 3 of those today. It's kind of amazing to see, and patients certainly enjoy that. Let's see what this next question says. How well does the iTero scanner do with subgingival margins, and do you still use conventional impression materials for these situations? To be very honest, we don't have any conventional PVS impression material in our office, period. We stopped using conventional impression material, I don't know, certainly 3, 4, 5 years ago. The rules apply the same. You have to have a direct line of sight. So that means an electrosurge, a laser, to be able to get any tissue that's in the way so that you have a direct line of sight. And of course, retraction cord to be able to expose the margin, or using electrosurge or laser to be able to expose the margin. If it's a very difficult case with deep subgingival margins and it's really, and that tissue is going to look rough anyway, it's often the case that then I might make a provisional, have the patient in a provisional until that tissue heals, and then take a separate visit. That is very, very, very rare. Most times, it's no problem to be able, with retraction cord and a little bit of patience, a good line of sight, to be able to do exactly the same thing that you would do with conventional impression taking, only do it better, quicker, using digital scanning. I had 2 crowns this afternoon on 2 bicuspids on the lower left, and they were very difficult, a lot of bleeding, and before the patient left, we simply walked away for a few minutes, came back, and we were able to get a digital scan using the Element scanner, no problem. I don't think there's a difference between impression taking, and I don't think you should look at it that way, as a difference between impression taking and management of the soft tissue. That really should be held on the same level. Sorry about that, folks. We had a little accident. Let's see if we can get reorganized here. Good to go. I hope I'm still up and running. I'm not sure exactly what's on the other end, but let's see if I can take another question. The sterilization of the tips, good question. There is a sleeve, a disposable sleeve that costs about $1. That sleeve is slips over the end of the wand and protects the wand, and that is the sterilization technique. Works well, easy to use. They come in boxes, cost $1 or so, no big deal. I will take any other questions. I think I'm still up and running here. We'll go right till 9 o'clock. I don't see any other questions here, Rich, unless anybody else has any questions. And I will say this. I'd like to put one more slide up. We do have 2 more sessions planned for the future. I want to talk just a little bit about those 2 more sessions, and then I think will take us right to the end. If there are any other questions, please, you can send those questions. I will try to get back to you. We can even talk about those questions, the answer to those questions, in our next session. These are the things, and just to kind of put a little excitement in where we're going to go, we're going to explore some really interesting things in the next 2 sessions. We're going to look at some case examples of scans that of things that we can do. Really, the top 12 things that the benefits that we have to a GP practice. We're going to talk about 3D printing. We're going to look at what 3D printers look like and their association with digital scanning. We're going to look at file merge, and file merge is going to be really interesting. We're going to take STL files, merge it with our DICOM files from our cone beam information, and create a virtual planning platform. We're going to then design where we want our implants to be. We're going to, from that information, create a surgical guide printed by our 3D printer, and yes, we can print those in our office. And at the same time, using a similar software, we're going to be able to create a provisional so that we can place the implant and place the provisional at the same time as surgery. Example, today I just had a patient. We did a 6-unit bridge on 4 implants. That restoration has been in the patient's mouth now for about 6 months, and we're going to put the final restoration in place on the original STL data that was derived when the implants were placed. In other words, the final restoration is going to seat on the original STL file for the predicted position created from the surgical guide. That's amazing stuff. And we'll look at some cases like that next week. So I think you'll find that pretty exciting. I'm looking forward to the session, and I hope to have all of you folks back again. And you can register. You see that at the bottom of the screen. And it's been fun for me, and I hope we can create some enthusiasm over digital scanning, 3D printing, in-office milling, and we will see you next time.